Hello everyone, in this video let us solve this question. So we have x raised to power x is equal to 55. So here, we have to solve for the value of x. So x is the unknown we have to solve for. To do this, solution. So right here, this question is that you will pick a number and then raise that number to that same number and the value must equal 55. So let's say we try 2. 2 raised to the same 2. This will give us 4 and this is not equal to 55. Now if you try 3, 3 raised to power 3, this is equal to 27 and it's obviously not equal to 55. Now let's say we keep on by testing 4. 4 raised to power 4 is equal to 4 raised to power 4. The value is 256 and this is also not equal to 55. But then looking at this, the value 55 we are looking for is in between 27 and 256. That is in between 3 and 4. So the range of values is 3 is less than x and this is less than 4. So to get the value of x that will give us 55, there's a much more easier way to solve this. So first we have x raised to power x is equal to 55. Now the first thing we're going to do is to introduce natural logarithm to both sides of the equation. So ln x raised to power x is equal to ln 55. Now this power x here, it will stay in this side following this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. So applying this rule right here, power x then becomes x times ln x, which equals ln 55. So right here we have x times ln x is equal to ln 55. Now at this junction, to solve this further, we're going to apply a function called the Lambert W function. So it's called the Lambert W function. Now, this function is going to be applied if you have an expression like this. If you have a times e raised to power a, if you apply the Lambert W function in this case, what you will get is a. Same thing also, if you have an expression in this format, y times e raised to power y, if you apply the Lambert W function, w to this, what you will get is y. So in this case, we are going to manipulate this expression, x times ln x, to resemble this expression. And to do so, this can be written as e raised to power ln x times ln x. This can be written as this. Now you're wondering, how come x? Now you see, if you have e raised to power ln x, this is equal to x. Why? Because e will cancel ln, x stands alone. So therefore, we can replace x with e raised to power ln x. So hence, x has been replaced with e raised to power ln x, then times ln x. So from here, we have e raised to power ln x times ln x equals, we have ln 55. So with this, to then solve this further, you see, making use of the Lambert function, you will see that e is in the second place. So move this to the second place. This becomes ln x times e raised to power ln x is equal to ln 55. So at this junction, we can then apply the Lambert W function. So w into bracket ln x times e raised to power ln x is equal to w times ln 55. Now at this junction, if you apply the Lambert W function to this expression right here, what we get is ln x is equal to w times ln 55. Good. So with this, to then solve for x, we're going to eliminate this ln here, and to do so, introduce e. So e raised to power ln x is equal to e raised to power w times ln 55. With this, e will cancel ln, x is then equal to e raised to power w times ln 55. So this is the value of x. But then, to get the value in numerical form, simply press in your calculator for the value of x, press E. Now, instead of W, you will press product log. So input product log, then multiplied by lane 55. If you do so, what you will get as the value of x will equal 3.3307 in 4 decimal place. So this is the value of x. So with this, if you have 3.3307 raised to power 3.3307, you will approximately get the value to equal 55. So we have gotten the value of x. That is the correct solution. So with this, I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.